Hi, I'm Chris, and in this video we're going to take a look at another problem from the Sanderson Test Prep SAT workbook. This is on page 79. This is number 3. If you want to take a look at the link here, you can click on it and watch an explanation of number 2 on that same page. But here we're dealing with a different parabola question. And we're given the equation of the parabola, and we're given this shape where we see the parabola, it crosses the x-axis here, the x-axis here, and it crosses the y-axis up here. And what the question is asking us is for the area of this rectangle, OPQR. So to find the area of that rectangle, I'll go ahead and put this over here. Area of OPQR is what we're looking for. So first of all, we need to know the equation for area of a rectangle. And what is that equation? So hopefully you might have said length times width. If not, since it is SAT, luckily, College Board, very nice. On the SAT Math, they will give you a chart at the beginning of each section that does tell you a few essential equations, and area of a rectangle is included there. However, realistically speaking, if you're looking for a really strong SAT Math score, basically anything up over that 500 mark, if that's your target, then you really do need to know all of those equations in that little chart. So that's something that it's worth just taking the time to make a quick flashcard and memorize. So area of a rectangle is length times width, which means we have to know the length and we have to know the width in order to solve for the area. So that means that we need to know, if possible, this coordinate and this coordinate. Those two coordinates for P and R will tell us how far we go from the origin here and how far we go from the origin here, which will give us the length and width of our rectangles. So if we notice, the first one, P, that we have here, it's the y-intercept. That's where our parabola crosses the y-axis. And to solve for your y-intercept in your original equation, you're always going to plug in 0 for x. So your y-intercept here, point P, when you plug in 0 for x, I get 2 times 0 squared minus 9 times 0 plus 9. And when you do the math on that, that comes out to be 9 for y. So for point P, the coordinate that you end up with is 0 for x and 9 for y, which tells us that the height of that point, it's 9 units above the origin. So we can put a 9 right there. And in finding our area, we need length times width. So we already have 9. Now we just need that other missing piece. We need to know how far r is from the origin on this. So similar process, except now we're trying to find the value of x when y equals 0. So to find coordinate r, let me just give myself a little room over here. So to find coordinate r, now since we're looking for an x-intercept, that means we're plugging in 0 for y. The y value is 0 when you cross the x-axis. So we're going to have 0 equals 2x squared minus 9x plus 9. And on this, to solve, anytime you have something set equal to 0, what you want to do, you could use a variety of ways of factoring, but you want to find a way to factor this in order to solve for that value of x where that's the case. You could also use your quadratic formula on this, but that's going to be a little bit more complex. And as far as SAT is concerned, you don't actually have to memorize quadratic formula. So if you don't know it, that's okay. You're still in good shape. For the SAT, you should be comfortable factoring quadratic equations, which means if you see an x squared, an x, and a 9, that's certainly an equation that you might be asked to factor on the SAT. And so we're going to go ahead and try to factor this here. In our parentheses, to multiply to get to 2x squared, that means that our first terms of each parentheses will be 2x and x respectively. And then they've got to be, for the numbers, they've got to be factors of 9. So we could either try 1 and 9 or we could try 3 and 3. If we put a 3 here and a 3 here, and we go to test it out, when you FOIL, remember you're doing first, outside, inside, last. 2x times 3 would be 6x. 3 times x would be 3x. And 6x and 3x can in fact give us 9x. Now since this is a negative in our equation, that means that each of these will be a negative. So when you FOIL it out, you'd get a negative 6x and a negative 3x, which gives you negative 9x. And when you multiply negative 3 times negative 3 for your last terms, you do get a positive 9. So we're in good shape. These are the factors of this equation. If you have questions on the actual factoring process, feel free to watch one of our videos on factoring. But for now, we're going to go ahead and finish out this problem. We're setting each one of these factors equal to 0 and solving. And when you do, you get 3/2 equals x, and you get 3 equals x. Now these will be the x values for your two x-intercepts. Let's take a look at our graph and see which one of those we might use. We have two x-intercepts. The one that we need for this rectangle is the one with the smaller value. So between 3/2 and 3, hopefully we look at this and we said 3/2 is the smaller value, and that will be this x-intercept. So point R will actually have a coordinate of 3/2, comma 0, which means that that's the value, 3/2 or 1.5 if you're more comfortable with decimals. That's the value that you're going to plug in for your width. And when you multiply that out for the area, you will get either 27/2 or 13.5 as a decimal. For more, please feel free to watch our other videos, and thanks for watching.